Thanks for joining us at 7:07. We're going back to the lab for more physics fun.
Wise guy Matt Sullivan is joining us live from his lab this morning, and today he's breaking glass using nothing but sound. Good morning, Matt.
Good morning, Robert. Hi, Gay.
How are you today?
I'm just great. Now, at the end of the last thing we did last week is I played around with a wine glass, you might recall, and I showed this phenomenon of resonance.
I remember because I couldn't do it.
Right. It takes just a very, very highly trained finger, just like this. I'm just kidding. And so we hear this nice loud sound that I'm just barely touching this glass. And the question I asked was, if I pour some water in here now, is the pitch of that sound going to get higher or is it going to get lower? And the correct answer was sent to me by Tiffany Hubbard of Tuscola, who's a 7th grader there, who thought about her musical instruments and figured this out. And she knew that it gets lower. So when I do this now, you can hear that you have a lower pitch. And the reason for this is that the frequency that something vibrates at has to do with a couple of things. How springy it is, and the springiness doesn't change by putting water in there, and also by how much inertia it has. And the water has the effect of increasing sort of the inertia of this cup, and so the pitch goes down. And you can see the water waves in there. You can play around with this at home. It's very cool. But the point here is that an object likes to vibrate at a certain frequency, and wine glasses have very specific and sharp frequencies that they like to vibrate at. And so I have over here a wine glass that I have set on this little tray. Right next to it is a speaker, and if I turn on this annoying sound generator and I put sound into the speaker at the exact same frequency, you're going to see that the glass starts to vibrate because that little piece of tape that's sitting on top is going to move.
Very good.
Okay, now it actually vibrates quite a lot. You can't see it unless I do this. I have a strobe light, and now I'm putting the strobe light on here, and this strobe light is going at about the same frequency as the speaker is, and as the glass vibrates. And when I turn it up, can you see the top of that glass kind of oscillating, sort of breathing? It kind of goes like this. If you look at the opening of the glass, it has that kind of a motion. Could you see that?
Yeah.
Okay, so what I'm going to do now is I'm going to turn the speaker up louder. That motion is going to get larger, and so we're putting more and more energy in at this one frequency. The amplitude of the motion gets bigger and bigger and bigger. It's like pushing a kid on a swing. If you keep pushing, eventually you can go right over the bar. Okay, so we're going to keep pushing by putting more and more loud sound into this glass, and eventually the oscillations are going to get so large that the glass is going to break. So let's just do that. Right, I better put on my purple glasses. It's very scientific piece of safety equipment here. Okay, so here we go.
Oh!
I love that. Okay, so it's not every week we get to break something, but, you know, it's a special week when we do.
That is true. Okay, do you have a question for next week?
Oh, absolutely, I do. And so we're going to continue with sound a little bit next week. And so here's the question. If when I speak and at a certain frequency, what happens is these pressure ridges come out of my mouth and go into your ear and wiggle your eardrum, and that's why you can hear me speaking. If I speak at a higher pitch, at a higher frequency, sort of a higher sound like that, are the little ridges that come out, these pressure ridges, is the wavelength, do they get farther apart or do they get closer together? In other words, if I have a higher pitch sound, are the waves closer together? That's the question, or are they farther apart?
Okay, and if you have the answer to that, you can email it to wiseguy@wiuc.edu. We also have a link to the Wise Guy's website from ours, wcia.com. Okay, thanks, Matt. Sorry you had to break a glass, but all in the name of science.
Oh, it was a pity. So I'll see you next week.
Okay.
Broke his heart to have to do that.